This is the second FRQ of the 2025 AP Calc BC exam. Part A asks, find the rate of change of r with respect to theta at the point on the curve where theta equals 1.3. The rate of change of r with respect to theta is just dr d theta. And we want this evaluated when theta equals 1.3, which is 1.031. Part B, we want the area that lies inside the curve C, but outside the polar equation r equals 1/2. So in other words, we want this area right here. Remember, if we're trying to find the area that lies between curves, we want to do integral of the outer curve minus integral of the inner curve. Now, in this area, C is always the outer curve with respect to the distance from the origin. So now to find these bounds of integration, we have to find where these two curves intersect, or we have to find where 2 sine squared theta equals 1/2. And we can actually find these bounds without the calculator. So from this equation, we deduce that sine of theta equals 1/2. And so if you know your unit circle, you'll know that these angles are pi over 6, which is right here, and 5 pi over 6, which is right here. That gives us an area of 2.067. Now, part C says we need to find the value of theta that corresponds to the point on curve C that is farthest from the y-axis, so like somewhere over here. This is pretty weirdly worded, but in essence, it's just asking you to find the maximum x in the interval 0 to pi over 2. Remember, if we want to find extrema of functions, we have to find the critical points by differentiating and then setting the derivative equal to 0 to solve for the critical points. Fortunately, they already gave us dx d theta. Now we have to solve this equation, dx d theta equals 0, and we're going to do that on our calculator. So in the calculator, I'm going to put in dx d theta, like so. Then we're going to shift our window to, let's say, negative 0.5 and 2, because we want to get the interval from 0 to pi over 2. When we put these settings in graph, and we have a 0 right there. So we find that by going to second calc, find the 0. It tells us our 0 is x equals 0.955. We can justify that this is the maximum by computing dx d theta a little before this and a little after this. To do that, we're going to go to our table. We're going to put in, let's say, 0.8. So that's positive, but if we put in 1, that's negative. So our derivative goes from positive to negative, or x goes from increasing to decreasing at this point. So we know this must be the maximum. Finally, part D, so we're going to find the rate at which the particle's distance from the origin changes with respect to time when the particle is at the point theta equals 1.3. They tell us find the rate at which the particle's distance from the origin changes with respect to time, or they want us to find dr dt. But the problem is, r isn't in terms of t, it's in terms of theta. And that's where we need to bring in this piece of information. By the chain rule, we know that this derivative can be broken up into dr d theta times d theta dt. And they want this evaluated when theta equals 1.3. In part A, we already found dr d theta at 1.3, which is 1.031. And here they tell us d theta dt equals 15. So we have 1.031 times 15, which is 15.465. And that's the second FRQ. If I made any mistakes, be sure to let me know in the comments and look out on my page for the next 4 FRQs.